Hello everyone, my name is Josh and today we will be learning list in Python. So list is a collection of comma separated heterogeneous values that are enclosed within square brackets, and it is a sequence data type in Python. Heterogeneous means different data types. And as we know, there are three sequence data types in Python: string, list and tuples. So one more information I would like to add is that lists are mutable data types. Like if we want to edit a list, or if we want to change a value or an element in the list, then we can do that after it has been created. So mutable data types are basically those data types whose values can be changed after the creation of the list, and immutable data types are those data types whose values cannot be changed after their creation. For example, tuples. Tuples are immutable data types because they cannot be edited or changed once they have been created. So let's start with creating a list. So we can, as you can see the syntax over here, we enclosed all the values and elements inside square brackets. And this is a list of integers, this one of strings, this is of characters, and this is of multiple data types. And this one contains a nested list. As you can see here, there is another list inside this list. So such a concept is called nested list. So we can create empty lists in Python using these square brackets and nothing inside. That is how an empty list is created. And let's move on to accessing elements of the list. So we can access each element of a list using this syntax. Here L means the name of the list, and we will be accessing the elements using the index. So we know that list has an index from 0, it starts from 0. As we know, Python has two types of indexing: positive indexing and negative indexing. So we can access the elements using any of the index. So we'll be doing with the positive as we are learning. So I can show you, I have created few lists over here. So if I want to access, let's say, the mango element in the first list, so I will access it using its index. So we know is that this is the 0th index, this is the first index. So I will be putting 1 over here and it will give me mango. So this is how we access an element using the index. Now as you can see that L2 has a nested list inside it. If I want to access, let's say, the element 9, how am I going to do that? Well, we'll be using this one, index of the nested list. We'll just be mentioning it outside. So first will be the index of this entire list, which is 0, 1, 2 and 3. So I'll be writing 3, and then the index of 9 in the nested list, which is 0, and it shows me 9. So this is how we access the elements of the list. Moving on to traversing a list. Traversing a list means accessing each element of a list, and traversing can be done in two ways. One is using the in operator, the membership operator, if we all know, inside a for loop. So here the elements can be accessed individually using for loop, and even using the range function, where we will be using the len function as well as the length of the list, and we'll be calculating using that. So we will be traversing a list using the in operator inside for loop. So let's see how it's done. So we'll be writing for I in L, because L is the name of the list, and print I. So this is going to give us the elements of the list. As you can see, apple, mango, banana and pineapple, these are the elements of the list have been printed out. Basically the list has been traversed. Now we'll be moving on to another way using the range function. So using the range function, let's see how it is done. So I'll be using the range function like this, and the start value will be 0 because it starts from the index 0, and length len of L, that is 4. And since we know that uh, the loop will run till 3 only, because its range runs till n minus 1, so it will be running till 3, and 3 is our last index. So that is all okay. So print L of I, and let's see. And as you can see, apple, mango, banana and pineapple have been printed, as you can see. So that is how traversing a list works. So now we'll be moving on to list operations. So Python provides us four operations, basic operations on lists, strings and tuples. Like these are the common operations that can be applied to strings as well, lists and tuples on all the sequence data types. So first one is the concatenation. This adds two lists to make a bigger list, and then is a replication. This is the replication operator. So this will replicate the list for a specified number of times. And third is the membership operator, in and not in. As we know, we used in over here. This is known as the membership operator. So we can use them as well. And fourth one is a slicing. And slicing is the same as string slicing as well. So all it does is list slicing uses indexes, nothing else. It returns a list from a given range of indices. So list slicing is done the similar way as string slicing and tuple slicing. But the only difference we should remember is that slicing a list will return a list. Like slicing any sequence data type returns the slice as the same data type. If we are slicing a tuple, it will return a tuple. If we are slicing a list, it will return a list. And if we are slicing a string, it will return a string. So let's go how slicing and everything works. First, let's try concatenating. So let me make a list over here. Let's say 1, 2, 3. And I want to concatenate with another list. Let's say 4, 5, and 6. So this concatenation gives us a list where both the lists are concatenated into one list. Next, let's say this is a list. Let's see how replication works. So let's say I want to replicate this 3 times. So I'll be using this, and one thing that we should remember is that the second one, like the second parameter we pass for replicating the list, it must be an integer, or else Python will give an error. So we can also use it in this way. If I put 3 first and the list again, then also it will give the same output. So as we can see that 1 to 3 has been replicated 3 times. So this is how replication and concatenation works. Next we have slicing. For slicing I have the list L3 created. So we'll be performing slice operations on that. So slicing is done using the square brackets. So as we can see, the syntax for slicing is this: the start colon end colon step value. So let's say that there's only one slicing operator given, and that's 10. Starting from 10, the slice is being given in this way. Then the slicing will start from the 10th index and it will continue till the end. So we know the 10th index does not exist in this one. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. There is no 10th index. But I have given over here 10th index till the end. So basically it will return an empty list. Now if I slice it from 4th index, it will slice from the 4th index till the end of the list. L3 is equals to, and if we'll be slicing, if you want to slice the list in the reverse order, then we can do one thing. Let's say that I want to slice a list from the 9th index to the 0th index. I'll be using -1. And over here, the 0th index, that means 1 less than this index. So it will not include 1. So let's see what the result is. As you can see, it has entered all the elements in reverse order except 1. But if I want 1 also to be there, I'll be slicing it using this. When I don't enter any input or parameters in this, the Python interpreter understands that it has to print the entire list. And the -1, the step value is negative, in order to explain the interpreter that I want the uh, slice to be returned in reverse order. So as we can see, 19, 17, 15, 13, 11, and it is printed in the reverse order. We can also skip some values, like let's say 1 to 9 and with a step value of 2. So that will skip 2, so it will take every second element. Let's say 3, then it will skip 5 and it will go to 7. It will skip 9 and it will go to 11. So like this up to 15. So if I want a list slice to be printed in a reverse order of step value minus 3, then I can do it in this way. Here I have used the negative indexing. For those who don't know what negative indexing is, it starts from right to left, from minus 1 to the length of the list basically. So if this is the minus 1th element, this is minus 2, this is minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, and minus 10. So I'm printing from the minus 1th index to the minus 9th index and with a step value of 3. So this is how it will be taking every third term from the index. So if this is the minus 1th index, this is the first term, this is the second term, and this is the third term. So it will be printing this one. So that's how the step value occurs in the reverse order. And let's try to experiment. If I try to print L3 from minus 1 to minus 10, since we know minus 10 means this, so and we'll give the same step value minus 3. So here you can see 7. After 7, this one was supposed to be printed, but since we know that the list slicing always prints the n minus 1th index element, it never prints the nth index. Whether it's in negative indexing or in positive indexing, it will never print the nth index element. It will always print till the n minus 1th index element. So that is list slicing, and I would like to add a point that slicing any sequence data type returns the slice as a same data type. So for example, if you are slicing list, it will return a list, and if you are slicing a string, then it will return a string. If you are slicing a tuple, it will return a tuple. So this is the only difference that slicing has. And next we'll be moving on to list functions and methods. Python offers many built-in functions and methods for list manipulation. And here are the methods. There are around 10 methods for list manipulation, and the first one is the len method. We use this many times. This basically returns the length of the argument. Here the argument can be any argument. This is a common function. Over here, if I see, let's take the list L. It has 4 elements, so the length of the L is 4. So let's say len of L, len of L, and that gives us 4. So now we'll be moving on to the next function, that is index function. This function returns the index of the first matched item from the list. So this is the syntax of the index function. And here item, basically we are supposed to enter the value or the element in the list whose index we want to find. So let's go and enter, let's say I want to find L dot index. Let me write the function first. I want to find the index of, let's say, banana. Python is case sensitive, so yeah. So I wanted to find the index of banana. It says index is 2. Let's see, 0, 1, and 2. Yes, it's correct. So this is the index function. Next we have the append function. The append method adds a new item to the end of the list. This is the syntax for it, and let's try it out. For example, L dot append, let's say I'm appending 2. Let's print list. As you can see, the 2 has been appended or added to the list. Append function adds the element at the end of the list. That's one thing to remember. And moving on to the next function, the extend function. This method is used for adding multiple elements given in the form of a list to an already existing list. So basically, if I use extend, let's say I'm extending. By the way, we can use a string or a list or a tuple, but we cannot use any other data types other than the sequence data types. So let's use list as of now. Let's say 1, 2, 3, and 4. So this is a list that I will be extending. So what the extend function does is that it adds these elements as a separate element in the list. It adds the list as a separate element in the list. As you can see here, all the elements are separately an element in the L. So moving on to the next function is the insert function. This function can be used to insert a new element at a specified index. It takes two arguments. One is the index where an item is to be inserted, and other is the item itself. So let's try it out over here. As we can see, this is the list before inserting the blue element, and I use this. This is the syntax. I inserted the blue element, and as we can see, the blue element is on the 0th index of the list. Moving on to the next function, we have the count function. This function returns the number of occurrences of a particular item present in the list. So let's see. Let's say the count of 2, and 2 occurs 2 times, so it has printed 2. It occurs here and here. So yep. And let's say count of high. Now high is not there in the list, so it returns 0. Next function we have over here is the reverse function. This function reverses the order of elements in a list. It places a new value in place of an item that already exists in the list, which means that it does not create a new list. Let's see how it works. As we can see over here is that L3.reverse. This is L3 initially, and when I reverse it, this is L3 in the reversed form. So yeah, this has reversed the list. The next function we have is the clear function. This method will remove all the items from the list, and it does not take any parameters, and it only empties the given list. It does not return any value. So let's see. We had a list L2. Let's say L2.clear, and now L2 is nothing but an empty list. All the elements inside L2 have been deleted. Moving on to the sort function. This function sorts the items of the list either in ascending order or in descending order. The default order is ascending. So let's see how it works. As you can see, L3.sort. So 1, 3, 5, 7, it has sorted in this way. Last time L3 was this, but after sorting it, L3 is this. L3.sort reverse equals to true. This sorts the list in the reverse order. Next function we have is the sorted function. This takes the name of the list as an argument and returns a new sorted list with sorted elements in it. And this works with all sequence data types. And the syntax is this. So let's work it out. Let's say sorted of let's say L3. That will give us 1, 3, 5, and 9, the sorted list. And if I enter sorted of L3 comma reverse equal to true as the second parameter, then we get the list printed in its descending order. So that is all of the functions. Next we will be moving on to the deletion operations in a list. Python provides functions for deleting or removing an element from a list. There are three methods for deletion. If you know the index of an item, then we can use pop function or the del statement. And if we know only the element and not the index, then we can use the remove function. So to remove more than one element, we can use the del with list slice. So I'll show you how it is done. First let's start with the pop function. So let's say I want to pop say L3. I want to pop L3.pop. If I use it without any parameter, then the last element is popped. Basically, the pop function removes the element from a specified index and also returns the element which was removed. If no index value is provided in pop function, then the last element is deleted from the list. So as we can see, the last element has been deleted from the list. Now moving on to popping the function, popping the list using 3. So over here, 3 is the index that I have entered. So 0, 1, 2 and 3, which means I want to pop the element at index 3, which is 13. So it returns 13 and removes the element from the list. So we have over here 19, 17, 15, 11, 9, 7, 5, 3. There is no 13 in it. 13 has been removed. The next method is the remove method. It is used when we know the element to be deleted but not the index of the element. So the syntax is l.remove element. Let's work it out. Over here I have written l3.remove 19. I want the 19th element on the index 0 to be removed. But let's say that I don't know the index of 19. So I just say l3.remove 19 and it removes the 19 for me, and as you can see the list over here does not contain 19 as the element. Moving on to the del statement. It removes a specified element or a range or slice of element from the list. The syntax is this. Let's try it out. Let's say I want del L3, and let's say from the first to second, third and fourth. I want these three elements to be deleted. So I will write 1 and 4. So as we can see that this particular slice has been deleted from the list. So this is how the deletion operations in the list work. We will be moving on to the maximum, minimum and sum functions. These are exclusive functions of the list and they also work for tuples. So here the max returns the element with the maximum value, the min returns the element with the minimum value, and the sum returns the sum of all elements from the list. So let's try to work it out on L3. It's sum of L3. So that will give us 32. If we sum up all these elements, that's going to give us the number 32. And if we try to get the max of L3, then the maximum is 17. And if we try to get the minimum of L3, we can see that 3, which is the minimum in the list, is being returned. So this is how, this is all about list, and this is how the functions of the list work. So this is all about list. So meet you in the next video. Till then, bye bye.